Hello, and welcome to this lesson on converting concentrations between grams per decimeter cubed and moles per decimeter cubed. In today's lesson, we will explore step-by-step methods to convert concentration from grams per decimeter cubed to moles per decimeter cubed, and vice versa. So far, you've become familiar with calculating the concentration of a solution in terms of both mass per volume and moles per volume. Understanding these basic concentration calculations forms a crucial foundation for today's lesson. Building on this foundation, today's lesson will enhance our chemical understanding by bridging these two ways of expressing concentration. This is important because it allows us to interchangeably use mass and moles, providing greater flexibility and precision in solving chemical problems. To understand how to convert concentrations between grams per decimeter cubed and moles per decimeter cubed, we start by applying a simple step-by-step approach to an example question. Suppose you have a solution with a concentration of 23.4 grams per decimeter cubed of sodium chloride, NaCl, and we need to convert the mass from grams per decimeter cubed to moles per decimeter cubed. First, we need to identify the concentration given, which is 23.4 grams per decimeter cubed. This means that 1 decimeter cubed of the solution contains 23.4 g of sodium chloride. We need to convert the mass to a number of moles. To do this, we need to find out the molar mass of the solute. Sodium has a relative atomic mass of 23 grams per mole, and chlorine has a relative atomic mass of 35.5 grams per mole. The molar mass of sodium chloride is therefore 23 grams per mole plus 35.5 grams per mole, which is 58.5 grams per mole. To convert the mass of the solute to moles, you divide the mass of the solute, in grams, by its molar mass. So the number of moles of sodium chlorine per decimeter cubed is calculated by dividing 23.4 grams by 58.5 grams per mole, equal to 0.4 moles. Hence, a solution with 23.4 grams per decimeter cubed of sodium chloride has a concentration of 0.4 moles per decimeter cubed. This can be summed up into one equation. Concentration in moles per decimeter cubed is equal to concentration in grams per decimeter cubed divided by molar mass in grams per mole. We can also do the opposite conversion. Now we'll convert moles per decimeter cubed to grams per decimeter cubed. Suppose you have a solution with a concentration of 0.5 moles per decimeter cubed of sulfuric acid, H2SO4. We want to find the concentration in grams per decimeter cubed. First, identify what's given in the question. We are told that sulfuric acid has a concentration of 0.5 moles per decimeter cubed. This means every 1 dm cubed of the solution contains 0.5 moles of sulfuric acid. We need to convert the number of moles to a mass. To do this, we need to find out the molar mass of the solute. Hydrogen has a relative atomic mass of 1 gram per mole, sulfur has a relative atomic mass of 32 grams per mole, and oxygen has a relative atomic mass of 16 grams per mole. Hence, the molar mass of sulfuric acid is equal to 1 gram per mole multiplied by 2, as there are 2 hydrogen atoms, plus 32 grams per mole, plus 16 grams per mole multiplied by 4, which in total is equal to 98 grams per mole. To convert the number of moles of the solute to a mass, you multiply the number of moles of the solute by its molar mass. The mass of H2SO4 per decimeter cubedis equal to 0.5 moles multiplied by 98 grams per mole, which is equal to 49 grams per decimeter cubed. So, a solution with 0.5 moles per decimeter cubed of H2SO4 has a concentration of 49 grams per decimeter cubed. This can be summed up as the equation. Concentration in grams per decimeter cubed is equal to concentration in moles per decimeter cubed multiplied by the molar mass in grams per mole. By understanding and applying these conversions, you can easily switch between the two concentration units depending on the context of the problem you are solving. Let's dive into some GCSE level questions to apply our understanding of converting concentrations between grams per decimeter cubed and moles per decimeter cubed. Suppose you have a solution with a concentration of 1 moles per decimeter cubed of sodium chloride, NaCl. What is the concentration in grams per decimeter cubed? Sodium has a relative atomic mass of 23 grams per mole, and chlorine has a relative atomic mass of 35.5 grams per mole. Pause the video here and have a go at this question. First, identify what's given in the question. We know sodium chloride has a concentration of 1 moles per decimeter cubed. This means every 1 decimeter cubed of the solution contains 1 mole of sodium chloride. To find the molar mass of the solute, we use the relative atomic masses of sodium and chlorine. Hence, the molar mass of sodium chloride is 23 grams per mole plus 35.5 grams per mole, which is 58.5 grams per mole. To convert the number of moles of the solute to a mass, multiply the number of moles of the solute by its molar mass. The mass of sodium chloride per decimeter cubed is 1 mole multiplied by 58.5 grams per mole to get 58.5 grams per decimeter cubed. So, a solution with 1 moles per decimeter cubed of NaCl has a concentration of 58.5 grams per decimeter cubed. Let's try another question. Suppose you have a solution with a concentration of 40 grams per decimeter cubed of acetic acid, CH3COOH. What is the concentration in moles per decimeter cubed? Carbon has a relative atomic mass of 12 grams per mole. Hydrogen has a relative atomic mass of 1 gram per mole, and oxygen has a relative atomic mass of 16 grams per mole. Pause the video here and try this question. First, identify what's given. In this case, CH3COO having a concentration of 40 grams per decimeter cubed. This means every 1 decimeter cubed of the solution contains 40 grams of CH3COOH. We need to convert the mass to the number of moles. To do this, we need to find out the total molar mass of the solute. Hence, the molar mass of CH3COOH is the relative atomic mass of carbon, 12 grams per mole, multiplied by 2, combined with the relative atomic mass of hydrogen, 1 grams per mole multiplied by 4, plus the relative atomic mass of oxygen, 16 grams per mole multiplied by 2, which comes to a total of 60 grams per mole. To convert the mass of the solute to the number of moles, divide the mass of the solute by its molar mass. So the number of moles of CH3COOH per decimeter cubed is 40 grams divided by 60 grams per mole, which is 0.667 moles per decimeter cubed. So a solution with 40 grams per decimeter cubed of CH3COOH has a concentration of 0.667 moles per decimeter cubed. By working through these examples, you can see how to handle different types of questions involving the conversion of concentrations between grams per decimeter cubed and moles per decimeter cubed. In today's lesson, we focused on understanding how to convert concentrations between grams per cubic decimeter to moles per cubic decimeter and vice versa. We explored the formula for converting these concentrations, first from grams per decimeter cubed to moles per decimeter cubed, which involves dividing the mass concentration by the molar mass of the solute. Conversely, to convert from moles per decimeter cubed to grams per decimeter cubed, you multiply the molar concentration by the molar mass. Through various examples and practice problems, we reinforced our understanding of these conversions. By the end of the lesson, you should be adept at switching between these 2 units of concentration. This knowledge is fundamental for accurately measuring and utilizing chemicals in both academic and professional settings.